All right, now let's look at how to print a schedule. And this will be an application of file input and output. So what I'm wanting to do is to take a class schedule for college and print it out. So essentially you'd have, Monday, Tuesday, Wednesday, Thursday, and Friday, and then show it you're taking certain class. You're taking an English class here, and maybe here, and then, maybe here you take a math class, and here, and so forth. So I'm wanting to build this and print it to the screen. So let's see how to design that. So let's see what we're starting with. So here's my data. So I have a header line that tells me what the columns represent. So this is the student, it's me. This column is the course I'm taking, CSC 2315, CSC 1310, and so forth. And these are the days of the week, these 5 entries here. And these are basically a binary representation. A 0 means that the class does not take place on that day, and a 1 means that it is. So this says that this course right here that I'm signed up for will be on Tuesdays and Thursdays. And then the last column is the time that the class starts in military time. Putting things in military time makes these types of things much easier, because now I don't have to try to figure out, given 8 a.m. and 8 p.m., well, which one came first? It's just much easier to have military time because it's easy to decide what the order should be. For my program, though, I don't necessarily have to have these already in order, as you can see here. So this is really at the end of the day. Here's the beginning of the day. These are in the middle. I made some simplifying assumptions here for this program. One is that each class really only takes place for an hour, or at least starts on the hour, which isn't realistic in many cases, because while this is a Monday, Wednesday, Friday class that might be 50 minutes each day, Tuesday, Thursday classes are typically 80 minutes each day. But I've done that just to make the overall process easier, right? So this is what I'm starting with, and here's what I want the final product to look like. All right? So you can see here my earliest time was 11 a.m. That's what I have here. The latest time was 1600 hours, which is 4 p.m. That's right here. Here's the classes. I have a couple time slots that are empty. Okay. I don't write the days of the week because it's more obvious that we know this is Monday, this is Tuesday, Wednesday, Thursday, Friday, but I could. But I've then filled this in. So my goal is to go from this file to this output and to be able to change it. So if I said, sorry, wrong data file. So let's say we added in philosophy 2301, and we say it's at 6 o'clock at night. There it is. I just added it. It was that simple. So this is why it's an application of file I/O. I didn't have to change my program. I just changed the data file and then read the new data file and fill it in. All right. So just to make some of the stuff I'm going to show you later easier to write, I'm going to get rid of that line because now I only have 5 lines of stuff to deal with. All right. Let's make sure it still works. So how do we get there? Let's look at the design part. So for my designs, I almost always start off doing them on paper like this, because I'm trying to understand, how do I make my decisions? It's easy to think, oh, I just know how to do it. But computers are dumb. What they are good at is following directions. So they need you to give them directions of what you do. And so to do that correctly, you need to understand how you do it. So I'm looking at the schedule and trying to figure out what's going on. And one of the things I prefer is my schedules to basically show only the necessary rows. So I don't have any classes before 11 a.m., so I don't want to show anything for 11 a.m. And I don't have any classes after 1600 hours, so I don't want to show anything here, Because imagine that I had classes start at 8 o'clock at night. Well, do I want to have the schedule start at 8 o'clock in the morning and, have 12 hours of nothing there? I don't. But if there are blank rows in here that should be used as filler, I want those, because leaving those out makes the time look wrong, right? If I only really had 2 rows and this was 11 a.m. and this was, say, 1,500 hours, well, it looks like the classes are back to back when they're really not. There would be a 4-hour gap. So I want to at least include any blank rows if they're really in there. So we'll put something else on here. Let's say this CSE class. So to do that, I need to know what's the min time and the max time. So I'll have to figure that out from the schedule. What else do I want to do? Well, when I'm making the schedule, if I had an empty schedule like I started with, if I knew it started 11 and then we have 12 and all the way down to 16, if I had that data file, schedule.csv, and I'm not going to replicate the whole thing, but just to make clear, if I had something like this, if I had, CSE 1310, and let's say it's at, I'm going to write it in English here, Monday, Wednesday, Friday, 11 a.m. Well, then I'd look on here and go, oh, well, this is CSE. I'll just put CSE to make it easy. CSE. And if I said, well, okay, I have IE 1401, and it's Tuesday, Thursday, and it's at 12 o'clock. Okay, I'd say, okay, I have IE, and then maybe I have one more, math 1426. Maybe it's also Tuesday, Thursday. It's at 1,600 hours. So this will be my math class and my math class. So I'm starting to look at a few things. What do I notice? Well, one thing I noticed on this has to do with column widths. All the course numbers are 4 digits, but the departments are 2 to 4 characters. IE is 2, math is 4, CSE was 3. So I probably want to deal with that when I'm printing this stuff out, because I'm trying to figure out what's the width here. That's going to be based upon the largest, right? So if I have math space 1426, well, that's 9 characters right there. So each column needs to be at least 9 characters in width if I want consistency. And then I can deal with the spacing within that. So that's something to consider. What else do I need to know? Well, if I'm wanting to print this, how do I know what to print? Well, obviously, I need to print the things that have the labels in them, right? The courses. But what about this? Well, in terms of printing, if that's empty, I don't want to leave it out and put all the CSE classes together. I want to pad it with spaces. So empty slots need to be padded. Pad empty slots. Okay? And so how do I know what an empty slot is? Well, for my design, basically what I'm going to do is I'm going to start with an empty table. I say empty, it's not actually going to be empty. This won't be quite right. And what I'll do is I'm going to start off by putting zeros in the table. I'm going to use min and max time to figure out how many rows to make. I know it's going to be 5 columns because I represent the 5 days of the week we typically have classes, but min and max time will determine how many rows. I'm going to go ahead and initialize everything to 0 because zeros will be my way of representing empty slots. And then what I'll do is I'll go through my schedule and write the course names like I did here into certain slots. I'll just put X's there to make it to show where they're at. And then when it's time to print, if there's a 0, I pad with spaces. Otherwise, I print the string that's there. So that's my design. So I start with read in the data. I need to tokenize it because it's going to come in. I'm going to have it in a comma separated file, comma separated values, excuse me. So I'm going to tokenize to get the parts. I need to look at the times. So I need those parts. I need the names, things like that. So read the file, break it up into parts, build the table, the initial table, populate the table with the names, then print the table. That's my process. So let's see how I did this. All right, so here we're at the bottom. One of the things I like to do also in the programs that I write that read files, especially for something like this where the data file is relatively small, and I like to include a copy of it so when I come back later and look at the program, I can easily see what I was working with. All right, so here's where we start. Open up the file, read the lines, and save the data. That's what this is. So data here will be the initial file. So let's go here and look at some stuff. And I like to do this as I do my development. I want to make sure that the data is in the form I think it is. So let's print data. And then I'm going to put an exit in here. So the exit function will cause the program to exit at this point, so I won't get to these lines. So I won't see the schedule here. I just will see the part I want to look at. And I didn't save it. That's the reason why we didn't get that. Okay. So there's data. So it's a list. And so here I have this string. That's my first string. Then I have my second string, my third string, and so forth, where each of these represents a row in the file. And it appears as a multi-line file because of the new lines that are at the end. And another thing, I need to get rid of the header line. That's great for me looking at it to understand what the columns are. But then when I'm processing the data, this isn't part of this. So I need to skip over that. So I need to make sure I deal with that. And by printing, I reminded myself that that's what I need to do. All right? So what do we need to do? Well, I'm going to get rid of that from data, and I do that right here. So if I have a list and I say pop 0, if I just say pop, I get rid of the last thing that's in the list. Pop 0 says get rid of the thing that's at index 0. So I just got rid of the header. So if we were to look at this, now I move down to this point. Let me clean some stuff up here. Now we can see the header is gone. So I'm confirming that I really did what I wanted before I get into doing the other things. All right, so now to have that working, we'll just do this each time. Or actually, I'm going to do this. I'm going to comment out those lines, and we'll look at things at one time. So let's start with min time and max time. (11) and 16. So there's my 11, there's 16. So those are the correct times. Let's see what this function does. So I'm simply just finding a min time and a max time. So I initialize my two variables here to values that I know will work. So I know that the min time should be early in the day, right? 23 is the last hour of the day in military time. That's 11 p.m. And the max time is midnight. So it's the beginning of the day. So any max time I find should come after this. Any min time I find should come before this. So I'm going to take each line of the data that I had there. I'm going to tokenize it. Get what was index 7. So this is column 1, or excuse me, index 0, 1, 2, 3, 4, 5, 6, 7. So I'm getting these values here, turning them into an int because they're really strings right here, and then simply look at getting the min and the max. So even though Python has a min and max function, and maybe it would work in this case, this is why you need to know how to do fundamental things yourself. So this simply goes through and finds the 11 and the 16 and returns them. All right? So now I'm going to take those values and build my initial empty table. So let's look at build 2D. So here's my times. So I'll start with an empty list, which I call structure here. And then as long as the time is less than max time, I start at that value. As long as it's less than or equal to the max time, I'm going to keep adding these rows of 5 zeros. That's all it does. So when we get to this point, let's see what we get. There it is. So 11 a.m., 12 a.m., or excuse me, p.m., 1,300 hours, 1,400 hours, 1,500 hours, 1,600 hours. There's my two-dimensional list of all zeros that I start with. So now we want to populate the schedule. So let's see how to do that. Now, conceptually, this is the most challenging part of the entire program. And let's see how this works. So let's start by remembering that what we have here. Here's the hours of the day. So 11 was my min, and it's in column index 7. All right, so how do I take these values and turn them into something? And remember right here, these represent the days of the week. So if I have a 1 in that column, that means there is something to be placed into that cell of the table. If there's a 0, then it's just going to be left as a 0 because it's really going to be padded with spaces later. But let's look at a problem here. So my table starts off looking like this. And I'm just showing 4. We'll go ahead and add a 5th column. All right. So this is row index 0, row 1, row 2. This is column index 0, 1, 2, 3, 4. But I want 11 a.m. to be here. Right? And since we had a line from the file, might have something like this, 0, 1, 0, 1, 0. But it had some other stuff before it, right? So these are really indices, 2, 3, 4, 5, and 6. So these are indices. These are the values. So I would like to somehow use the indices of these to figure out where I'm at here. So I need to create a mapping. So what do I need to do? Well, if there's a 1 at index 2, then I need to do something at 0. So when I see 2, then I do something. In column 0. And when I see 3, 1, 4, 2, and so forth. So what's the relationship here? 2 minus 2 is 0. 3 minus 2 is 1. 4 minus 2 is 2. So it's really a mathematical function. That's how I'm going to determine the column index of my table based upon the column index of the string. And then the row index is something similar. In this case, min time is equal 11. So when I see, let's say it that way, 11, I need to use row 0. 12 is 1. 13 is 2, and so forth. So what are these? 11 minus 11 equals 0. 12 minus 11 is equal to 1. 13 minus 11 is equal to 2, and so forth. So if I were to use the values as is, 11 and column 0, I I'd really be working with something out here, and I'm basically mapping it in this direction, shoving things over by 2 here and shoving things down by 11 here. That's what I'm going to do to find, if this is called, say, table. For the table row index, column index, this is where I use the mappings. So let's see what that actually looks like in code. So here I split a line, tokenize, and we know we're starting with day 2, and as long as we're less than day index 7, because that's actually the time, so we want to go to 6. If the value in that column, we're talking about these days of the week, is a 1, then I want to put what was in T1, that's the name here of the course, I want to put it into the table there. But look at how I get it. This right here, let me change this a little to make it easier to read. And I don't think I broke it. Actually, we commented some things out below, that's why I can't see it. Right? So what is this? So here's how I get the row index. So I take T7, that's this value right here, turn it into an int, and then subtract the min time from it. So 11 minus 11 is 0. And then I take whatever day we're on and subtract 2 from it to get the appropriate column index, just like I said. And then we increase the day, and we keep going. So that's how I populate the table or the schedule. All right? So that's how that works. So now, just to make sure I haven't broken this again, let's print the schedule. There it is. Let's see how that works. So we'll go to that function. So this will help me know how many rows and columns I have. So if you have a 2-dimensional list and you ask what the length of it is, it tells you how many 1-dimensional lists exist in it. So that's the number of rows. If each column of the table has if each row has the same number of columns, then I can ask how many columns are in the first row by saying what's the length of D0, because D0 is the first list in the 2-dimensional list. So that's how this works. So now I'm going to have a set of nested loops. And I start off by printing right here the hour, okay, which I pass in, so that's how I get 11. What did I actually pass in? The min time, as well as schedule here is my 2-dimensional table. And what Populate Schedule did was modify it. So we didn't show it actually here. Let's look at this real fast. So before we populated it, here's what it looked like. All zeros. Now that I populated it, let's see what it looks like. 1310, 0, 1310, 0, 1310. And then nothing at 12 o'clock. And then here's the math class, followed by English and stuff right there. All right? So we can see that that's working. All right. Sorry. So now let's look at Populate Schedule. So this right here prints the starting hour, and then eventually we increment here to get to 12, 13, 14, all the way to 16. Now I'm going to go through each column of the schedule and ask a question. So here where I wrote D is my schedule. If the value is a 0, then pad with 11 spaces. Why 11? Because remember, when I looked at these, I said the max width of a course name is 9 characters. So that gives me 1 space on either side. If I print something smaller like CSC 1310, well, one of the sides has to have more characters, and IE 3301, because IE only has 2 characters, has 2 spaces followed by 2 spaces here. All right? But regardless, they all take up 11 spaces. So here's 11 spaces that I pad with, and I'm suppressing the new line, so I keep printing across a row. And here's how I also get a vertical bar. But if there's not a 0 there, then I want to print the name of the course, and I use the center method for strings. So this takes whatever string you have, and this is a string. DRC is one of the strings in the two-dimensional list. This takes it and centers it, padding with with spaces on the left and right if necessary. So now I print that course name followed by a vertical bar, and then I suppress the new line. And once I've finished an entire row, then I want to print the new line, so I come down to the next row. What does this do? Well, I start off by printing a couple of spaces right here, and then this right here says print 61 dashes. That's what this does. So that's legal in C, but wouldn't be illegal in some other languages. So that's how I get all these dashes without me physically typing in 61 dashes. And then once again, I update the hour, update which row we're on, and then I move up and go to the next row. And that's the whole program. But you have to think your way through it, and my preferred way of doing it is sit down and draw it on paper. Or write pseudocode. Sometimes I can do that because conceptually I might say something like, for each line of the file, do this with a line. As long as it makes sense to me. But the whole point is to get to where you understand enough to write the code. And then hopefully, if you're new to programming, you're starting to see how I decide what to make a function. Functions should be things that really do a particular task. So like this function, it simply finds the min and max of the data. This function builds an empty schedule. This function populates a schedule. This function prints a schedule. Each of those is a separate task. Could I have taken all the code of each of these functions and put it right here? Sure. But then it would make the code harder to read. And then if I want to make changes to it, it can make changes more difficult. Because what if I want to write a different version of one of these functions? Well, I might come down and do something like this. I might have, like instead of this version, maybe I comment that out, and now I have time range 2. So instead of messing up the original function, I just make a copy of it or start from scratch and create an alternate version. And this way I can easily use the other version without messing up my first version. All right. So that's the application for File.io. If you find videos like this helpful, help me out by hitting the subscribe button and also hitting the like button to let me know that you're enjoying the videos.